Let's rewind the clock a bit. Picture the abacus. Yes, that ancient tool used by Greeks and Romans. It helped with basic calculations and some might argue was the very first computer. It sparked an idea. What if we could automate this? In 1642, a French mathematician named Blaise Pascal built the first mechanical calculator. Fast forward to the 1800s and a machine called the Jacquard loom used something revolutionary: punch cards. These cards told the machine what to weave, acting as the very first code. This idea inspired an inventor named Charles Babbage to design the analytical engine, a fully programmable mechanical computer. Working with him was Ada Lovelace, who wrote the first algorithm for it, making her the world's first computer programmer. The modern age of computing truly began in the 1940s. The first generation of computers were powered by fragile vacuum tubes. You see, these were machines like the ENIAC, and they were so massive, they took up entire rooms, consumed a huge amount of power, and generated enough heat to warm a building. And they were the fastest calculators the world had ever seen. But the giants had a weakness. So, in the 1950s, engineers invented the transistor. This tiny component replaced the clunky vacuum tubes, making the second generation of computers smaller, more reliable, and 1,000 times more efficient. They were still massive, but this was the beginning of the Great Shrink. The next giant leap was a tiny integrated circuit, a chip that could hold hundreds of transistors. This was the third generation. It drastically reduced the size and cost of computers, allowing them to finally escape the labs and enter offices. This is the era that gave us keyboards and monitors, the first real way for humans to talk to a computer. But the real breakthrough was the microprocessor. What if you could put an entire computer on a single chip? That's what Intel did in the 1970s. This fourth generation gave us the IBM PC and the Apple II, bringing the power of a room-sized machine right onto your desk. And today, we're in the fifth generation, the age of AI. Our devices don't just follow instructions, they learn. From the AI that powers your phone's facial recognition to the algorithms behind your voice assistant, computers are now thinking and interacting with us in ways we could only imagine. So what exactly is inside these machines? Well, every computer is made of two key things: hardware and software. Think of hardware as the body and software as the brain. Hardware is all the physical stuff you can touch, and at its core, every computer has 5 essential components working in unison. First off is the CPU, or the Central Processing Unit, the brain of the computer. It executes all the instructions and calculations. Next is the RAM, the computer's short-term memory or random access memory. It holds all the data the CPU is actively using right now. The more RAM you have, the more tasks you can run at once. Next is storage. This is the long-term memory, like a hard drive disk or solid-state drive, where all your files and applications are stored permanently. Next is the motherboard. This is the main circuit board that connects all the other components. It's the central nervous system that allows the CPU, RAM, and storage to communicate. Last but not the least is the GPU, or the Graphics Processing Unit. It specializes in rendering images and video, making sure what you see on your screen looks fast and smooth. If hardware is the body, then software is the set of instructions that tells the body what to do. There are 3 main types. First is the system software. This is the foundation. It includes the operating system like Windows, macOS, or iOS that manages all the hardware and allows other programs to run. Without it, the computer is just a collection of parts. Next is application software. These are the programs designed for specific tasks that you can interact with every day. The web browser you're using, the word processor you write with, or the video games you play are all forms of application software. Last but not the least is the programming software. This is a special category of software used by developers to create all the other types of software. Think of it as the tools used to build a house, including compilers that translate code into a language the computer understands, and debuggers that helps find errors. So, in short, the hardware provides the physical power and the software gives it purpose. Together, they have transformed our world, all because a few brilliant minds saw a simple set of beads and imagined a machine that could think.